Alright, so let's learn how to convert the other way. So given the first order system, let's learn how to convert it into a differential equation. Remember, for now, we don't know how to solve this for now. And for the regular differential equations, we pretty much know how to solve it. So converting this way is actually more beneficial because we already know how to solve differential equations for one functions. So let's directly do examples. So let's consider a first order system. X prime is negative 2y and y prime is 1/2 x. So this is the first order system. Well, let's first isolate x from the second equation. So if you want to isolate x, you multiply by 2 on both sides. So you get x equals to 2y prime. And differentiate with respect to t on both sides. We get x prime is 2y double prime. And take this, plug it into back in here. So we get 2y double prime equals to negative 2y, which means y double prime is negative y, which means y double prime plus y equal to 0. The characteristic equation is r squared plus 1 is equal to 0. So r squared is negative 1, r is plus minus I. So the solution for y is y equals to a times cosine t plus b times sine t. So y equal to a cosine t plus b sine t, and x, remember x is 2y prime, so it's gonna equal to negative 2a sine t plus 2b cosine t. So this is our solution. And if you're given the initial condition, so let's take new space. If you have the initial condition, because this is the first order system, so you need one initial condition per function. So we need an initial condition for each of x and y. So suppose we have initial condition x of 0 is equal to 2 and y of 0 equal to 0. Then we plug it into this. So x0 equal to 2 means 2b equal to 2. And y of 0 equal to 0 means a equal to 0. So the particular solution is x of t equals to negative 2a sine t by a is 0 plus 2b cosine t. 2b is 2, so b is 1, so it's 2 cosine t. Y equals to a cosine t, which is 0, plus b sine t, and b is 1, so y is equal to sine t. Alright, so let's do a different example. So let's consider the first order system. X prime is y, y prime is 2x plus y. So this is the first order system. We can do two things. We can isolate y from the first equation or isolate x from the second equation. It is harder to isolate x from the second equation because the first equation has y standing there. So let's do this. So because y equals to x prime, that means y prime is x double prime. And take this, you plug it into back in here. And don't forget, y equal to x prime, so take this, plug into back here. So we get is x double prime equal to 2x plus x prime. Well, now we only have one single function to solve. This is not hard to solve. We get x double prime minus x prime minus 2x equal to 0. The characteristic equation is r squared minus r minus 2 equal to 0. So r minus 2, r plus 1 equal to 0, r equal to 2, negative 1. So x equal to a times e to the 2r plus b times e to the negative r. Negative t, sorry. 2t and negative t. And remember from above, y equal to x prime. So this is equal to 2a e to the 2t plus minus b times e to the negative t. And if you're given the initial condition, again, because we only have first order derivative, so we need one initial condition, but we need one initial condition per function. So suppose we have initial condition x0 is 0 and y of 0 is equal to 1. This is not hard to solve. X0 equal to 0 means a plus b equal to 0. Y of 0 equal to 1 means 2a minus b equal to 1. Okay, so a plus b equal to 0, 2a minus b equal to 1. First one tells you a is negative b. Second one tells you negative 3b is 1, so b is negative 1/3. Negative 1/3, and which tells you a is 1/3. So the particular solution, is x equals to 1/3 e to the 2t minus 1/3 e to the negative t. Y is x prime, so it's 2/3 e to the 2t plus 1/3 e to the negative t. Alright, so that's how you convert these two things into each other. We're going to end the section with application in the next video.